Excessive current draw from multiple appliances connected to the same circuit or an undersized panel can cause a surge. The electrical system appears overloaded, with multiple appliances connected to improper circuits and an undersized 100 amps main breaker. Loose or damaged wires can cause arcs and surges. The cut wires in the trailer connection point to potential wiring issues. Defective appliances or electronics can draw excessive current, leading to surges. A power surge typically causes damage to the external components of appliances, such as cords or receptacles. If the radio's cord and receptacle were not melted, it may have been damaged by an internal fault rather than a surge. Also, if other nearby homes or businesses should have experienced a surge if it was caused by an external event such as lightning or downed power lines. Begin by thoroughly inspecting wiring. Check for loose or damaged wires throughout the house, especially in areas where appliances are connected. Next, verify appliance functionality. Test the affected appliances, such as the television, satellite, and radio, to determine if they are still functional. If not, the failure may have caused the surge rather than being a result of one. An undersized main breaker and overloaded circuits indicate a need to upgrade the electrical system to handle the current demand. This should include installing a larger main breaker and separating appliances onto dedicated circuits. It is important to educate the customer on the importance of proper electrical connections and avoiding overloading circuits. If the cause of the power surge cannot be determined, it is recommended that the customer contact a licensed electrician for further investigation and repairs. Electrical overload is a condition where the demand for electricity on the circuit or within an electrical system exceeds its capacity. This can happen due to several reasons, including too many appliances running simultaneously on the same circuit, appliances with high power consumption operating at the same time, or an undersized electrical panel or wiring for the total load. The consequences of electrical overload can range from tripped circuit breakers or blown fuses to more serious hazards like overheating, damage to appliances, and even electrical fires. Recognizing the signs of electrical overload and taking preventive measures are crucial for ensuring electrical safety. Symptoms of electrical overload include frequently tripped circuit breakers or blown fuses, dimming or flickering lights when appliances are turned on, outlets or switches that are hot to the touch, a burning smell coming from outlets or appliances, and visible sparks or smoke from electrical devices. To prevent electrical overload, it is essential to distribute the load evenly across multiple circuits. Avoid using multiple high-wattage appliances in the same circuit simultaneously. Upgrade the electrical panel and wiring if necessary to accommodate increased power demands. Use power strips with built-in surge protection and overload protection, and regularly inspect electrical cords and outlets for damage. Circuit breakers and fuses are safety devices designed to protect electrical circuits from overload. Circuit breakers are reusable switches that automatically trip and interrupt the flow of electricity when the current exceeds the rated capacity of the circuit. Fuses are one-time use devices that contain a metal filament that melts and breaks the circuit when an overload occurs. When a circuit breaker trips or a fuse blows, it indicates that the circuit is overloaded or there is a fault in the wiring. It is important to identify the cause of the overload before resetting the circuit breaker or replacing the fuse. Simply resetting the breaker or replacing the fuse without addressing the underlying issue can lead to repeated overloads and potential hazards. If circuit breakers frequently trip or fuses blow, it may be necessary to consult a qualified electrician to diagnose and resolve the problem. Faulty wiring refers to any defects or issues with the electrical wiring within a building or electrical system. This can include loose connections, damaged insulation, frayed wires, incorrect wiring configurations, and other problems that compromise the safety and functionality of the electrical system. Faulty wiring can pose significant risks, including electrical shocks, fires, and damage to appliances and equipment. Identifying and addressing faulty wiring is essential for preventing accidents and ensuring the safe operation of electrical systems. Common causes of faulty wiring include improper installation, aging and deterioration of wiring materials, damage from pests or rodents, water damage, and physical stress or strain on the wires. Signs of faulty wiring can include flickering lights, outlets or switches that do not work, outlets or switches that are hot to the touch, burning smells coming from outlets or appliances, and unexplained electrical shocks when touching appliances or fixtures. To detect and address faulty wiring, it is important to conduct regular inspections of the electrical system, use appropriate testing equipment to check for voltage drops, continuity, and insulation resistance, and hire a qualified electrician to perform repairs and replacements as needed. Additionally, it is crucial to follow electrical codes and standards during installation and maintenance to minimize the risk of wiring problems. Appliance malfunction refers to a situation where an electrical appliance or device fails to operate as intended or exhibits abnormal behavior. This can range from minor issues like a light bulb burning out to more serious problems like a motor failing or an electronic component malfunctioning. Appliance malfunctions can be caused by a variety of factors, including wear and tear, manufacturing defects, power surges, improper use, and lack of maintenance. Depending on the nature and severity of the malfunction, it may be possible to repair the appliance or it may need to be replaced. Common types of appliance malfunctions include electrical problems such as short circuits, open circuits, and component failures, mechanical problems such as broken belts, worn gears, and clogged filters, and electronic problems such as software glitches, sensor failures, and control board malfunctions. When an appliance malfunctions, it is important to take appropriate steps to diagnose the problem and determine the best course of action. This may involve consulting the appliance's user manual, performing basic troubleshooting steps, or contacting a qualified repair technician. In some cases, a malfunction may be covered by a warranty, in which case the manufacturer or retailer may provide repair or replacement services. To prevent appliance malfunctions, it is important to follow the manufacturer's instructions for proper use and maintenance, avoid overloading appliances, protect appliances from power surges, and schedule regular maintenance checks to identify and address potential problems before they escalate. Electrical repair involves the diagnosis, troubleshooting, and rectification of problems in electrical systems, equipment, and components. This can range from simple tasks like replacing a light switch to more complex procedures like rewiring a building or repairing a motor. Electrical repair work should only be performed by qualified and licensed electricians due to the inherent risks involved, such as electrical shock, fire hazards, and damage to equipment. Before beginning any electrical repair work, it is essential to de-energize the circuit or equipment by turning off the power at the main electrical panel. This helps to prevent accidental electrical shock and ensures the safety of the electrician. Common types of electrical repair work include repairing or replacing damaged wiring, outlets, switches, and fixtures, troubleshooting and repairing electrical appliances and equipment, diagnosing and repairing electrical control systems, and installing new electrical circuits and equipment. When performing electrical repair work, it is important to use the appropriate tools and equipment such as voltage testers, wire strippers, pliers, and screwdrivers. Additionally, it is crucial to follow all applicable electrical codes and standards to ensure that the repair work is done safely and correctly. After completing the electrical repair work, it is important to test the repaired circuit or equipment to verify that it is functioning properly and that there are no safety hazards. This may involve using a voltage tester to check for proper voltage levels, testing the operation of switches and outlets, and inspecting the wiring for any signs of damage or overheating. Electrical diagnosis is the process of identifying the cause of a problem in an electrical system or piece of equipment. This involves using various tools and techniques to gather information, analyze data, and pinpoint the source of the issue. Accurate electrical diagnosis is essential for effective troubleshooting and repair. The first step in electrical diagnosis is to gather information about the problem. This may involve interviewing the customer or user of the equipment to understand the symptoms and circumstances surrounding the issue. It may also involve reviewing maintenance records, schematics, and other documentation to gain a better understanding of the system or equipment. Next, the electrician will perform a visual inspection of the electrical system or equipment to look for any obvious signs of damage, such as broken wires, burnt components, or loose connections. They may also use their sense of smell to detect any unusual odors, such as the smell of burning plastic or insulation. After the visual inspection, the electrician will use various testing tools to measure voltage, current, resistance, and other electrical parameters. These measurements can help to identify faulty components, wiring problems, and other issues that may be causing the problem. Common testing tools used in electrical diagnosis include multimeters, voltage testers, clamp meters, and insulation testers. Once the electrician has gathered enough information and data, they will analyze the results to identify the root cause of the problem. This may involve using logical reasoning, troubleshooting charts, and their knowledge of electrical theory to narrow down the possibilities and pinpoint the source of the issue. After identifying the cause of the problem, the electrician can then proceed with the appropriate repair or replacement procedures to restore the system or equipment to proper working order. An electrician is a skilled tradesperson who specializes in the installation, maintenance, and repair of electrical systems and equipment. Electricians work in a variety of settings, including residential, commercial, and industrial buildings, and they are responsible for ensuring that electrical systems are safe, reliable, and compliant with applicable codes and standards. To become a licensed electrician, individuals typically complete a formal apprenticeship program which involves a combination of classroom instruction and on-the-job training. During the apprenticeship, they learn about electrical theory, wiring techniques, safety procedures, and relevant codes and standards. After completing the apprenticeship, they must pass a licensing exam to demonstrate their knowledge and skills. Electricians perform a wide range of tasks, including installing electrical wiring, outlets, switches, and fixtures, troubleshooting electrical problems, repairing or replacing faulty electrical components, and inspecting electrical systems for safety and compliance. They also work with a variety of tools and equipment, such as wire strippers, pliers, screwdrivers, multimeters, and voltage testers. Electricians must be knowledgeable about electrical codes and standards, such as the National Electrical Code, and they must follow these codes and standards when performing their work. They must also be aware of potential safety hazards and take appropriate precautions to prevent accidents and injuries. Home wiring refers to the electrical wiring system within a residential building. This includes the wires, cables, outlets, switches, fixtures, and other components that distribute electricity throughout the home. Proper home wiring is essential for ensuring the safety and reliability of the electrical system. Home wiring typically consists of several branch circuits, each of which provides power to a specific area of the home or to a specific appliance. Each branch circuit is protected by a circuit breaker or fuse in the main electrical panel. The wiring in a home must be properly sized to handle the electrical load it is expected to carry. Overloaded circuits can cause overheating, damage to appliances, and even electrical fires. The National Electrical Code provides guidelines for determining the appropriate wire size for different types of circuits. All electrical work in a home should be performed by a qualified and licensed electrician. Improper wiring can be dangerous and can lead to electrical shock, fire, and other hazards. When installing or modifying home wiring, it is important to follow all applicable electrical codes and standards. This includes using approved wiring methods, properly grounding electrical systems, and installing ground fault circuit interrupters in areas where water is present. Regular inspection and maintenance of home wiring is essential for identifying and addressing potential problems. This includes checking for damaged or frayed wires, loose connections, and overloaded circuits. If any problems are found, they should be repaired promptly by a qualified electrician. A circuit breaker is an electrical safety device designed to protect an electrical circuit from damage caused by overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then has to be replaced, a circuit breaker can be reset either manually or automatically to resume normal operation. Circuit breakers are typically used in electrical panels to protect individual circuits within a building. There are different types of circuit breakers, including thermal magnetic breakers, which use a combination of heat and magnetism to trip the breaker, and electronic circuit breakers, which use electronic sensors to detect faults. When a circuit breaker trips, it indicates that there is a problem with the electrical circuit, such as an overload or short circuit. It is important to identify and correct the cause of the problem before resetting the circuit breaker. Simply resetting the breaker without addressing the underlying issue can lead to repeated tripping and potential hazards. To reset a circuit breaker, first turn off all appliances and devices connected to the circuit. Then locate the circuit breaker in the electrical panel and flip it to the off position. Wait a few seconds and then flip it back to the on position. If the circuit breaker trips again immediately, there is still a problem with the circuit that needs to be addressed. If circuit breakers frequently trip, it may be necessary to consult a qualified electrician to diagnose and resolve the problem. Troubleshooting is a systematic approach to identifying and solving problems. It involves gathering information, analyzing data, and testing potential solutions to determine the root cause of the issue and implement an effective fix. Troubleshooting is a valuable skill in many fields, including electrical work, computer technology, and mechanical repair. The first step in troubleshooting is to clearly define the problem. This involves gathering information about the symptoms, circumstances, and history of the issue. It is important to be as specific as possible when describing the problem to avoid confusion and wasted effort. Next, gather relevant data and information about the system or equipment that is experiencing the problem. This may involve reviewing documentation, consulting with experts, and conducting tests and measurements. Analyze the data and information to identify potential causes of the problem. This may involve using logical reasoning, diagrams, and other tools to narrow down the possibilities. Once you have identified potential causes, test each one to determine if it is the actual cause of the problem. This may involve conducting experiments, making adjustments, and observing the results. After identifying the cause of the problem, implement a solution to fix it. This may involve repairing or replacing faulty components, reconfiguring settings, or making other changes to the system or equipment. After implementing the solution, test it to ensure that it has resolved the problem and that the system or equipment is functioning properly. Document the troubleshooting process, including the problem description, data gathered, analysis performed, solutions tested, and final resolution. This documentation can be valuable for future reference and for training others. The 2017 National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation in the United States. It is published by the National Fire Protection Association, or NFPA, and updated every 3 years. The NEC provides comprehensive guidelines for electrical wiring, overcurrent protection, grounding, and other aspects of electrical safety. It is designed to protect people and property from electrical hazards. The NEC covers a wide range of electrical installations, including residential, commercial, and industrial buildings, as well as outdoor installations and special equipment. It includes requirements for wiring methods, conductor sizing, overcurrent protection, grounding and bonding, and equipment installation. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical safety. It also includes tables and examples to help users understand and apply the code requirements. Some key areas covered by the NEC include general requirements for electrical installations, wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and communication systems. The NEC is enforced by local and state authorities who may adopt it as law or use it as a basis for their own electrical codes. Compliance with the NEC is essential for ensuring the safety of electrical installations and for avoiding potential liability in the event of an accident. It is important for electricians, contractors, and other electrical professionals to stay up to date with the latest version of the NEC and to follow its requirements when performing electrical work. Article 210.8 of the NEC covers ground fault circuit interrupter, or GFCI, protection for personnel. It specifies the locations where GFCI protection is required to reduce the risk of electrical shock. In dwelling units, GFCI protection is required for receptacles in bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens, and laundry areas. It is also required for receptacles within 6 feet of sinks, tubs, and showers. In non-dwelling units, GFCI protection is required for receptacles in bathrooms, kitchens, rooftops, and other wet or damp locations. It is also required for receptacles used for servicing appliances and equipment. GFCI protection can be provided by using GFCI receptacles or GFCI circuit breakers. GFCI receptacles are installed in place of standard receptacles and provide protection at the point of use. GFCI circuit breakers are installed in the electrical panel and provide protection for the entire circuit. When a ground fault is detected, the GFCI device quickly interrupts the flow of electricity to prevent electrical shock. GFCI protection is an important safety feature that can help to protect people from electrical hazards in wet or damp locations. It is important to install and maintain GFCI devices in accordance with the NEC requirements. Article 220 of the NEC covers branch circuit, feeder, and service calculations. It provides methods for determining the minimum size of conductors and overcurrent protection devices for electrical circuits and systems. The purpose of these calculations is to ensure that electrical circuits and systems are properly sized to handle the expected load and to prevent overheating and other hazards. Article 220 includes requirements for calculating the general lighting load, receptacle load, appliance load, and other loads that may be connected to an electrical circuit or system. It also includes requirements for calculating the demand factors that can be applied to reduce the calculated load based on the diversity of the loads. The calculated load is used to determine the minimum size of the conductors and overcurrent protection devices for the circuit or system. The conductors must be sized to carry the calculated load without overheating, and the overcurrent protection devices must be sized to protect the conductors from overload and short circuit. Article 220 also includes requirements for calculating the voltage drop in electrical circuits and systems. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause appliances and equipment to operate inefficiently or not at all. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. It is important to perform accurate branch circuit, feeder, and service calculations to ensure the safety and reliability of electrical circuits and systems. Article 250 of the NEC covers grounding and bonding. Grounding is the process of connecting electrical equipment and systems to the earth to provide a low impedance path for fault current. Bonding is the process of connecting metallic parts of electrical equipment and systems together to create an electrically conductive path. The purpose of grounding and bonding is to protect people and property from electrical shock and fire hazards. Grounding and bonding provide a path for fault current to flow back to the source, which causes the overcurrent protection device to trip and energize the circuit. Grounding also helps to stabilize voltage and reduce electrical noise. Article 250 includes requirements for grounding electrodes, grounding conductors, bonding jumpers, and other grounding and bonding components. It also includes requirements for grounding different types of electrical equipment and systems. The NEC specifies the types of grounding electrodes that are permitted, such as metal underground water pipes, concrete encased electrodes, and ground rings. It also specifies the minimum size of grounding conductors and bonding jumpers. Article 310.15 of the NEC addresses ampacity of conductors. Ampacity is the current, in amps, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. This section provides tables and guidelines for determining the ampacity of various types of conductors based on their material, size, insulation, and installation conditions. The ampacity of a conductor is affected by several factors, including the ambient temperature, the number of conductors in a raceway or cable, and the type of insulation used. The NEC provides correction factors and adjustment factors to account for these factors. It is important to select conductors with sufficient ampacity to carry the expected load without overheating. Overheated conductors can cause insulation damage, equipment failure, and even electrical fires. When determining the ampacity of conductors, it is important to consider the termination temperature ratings of the connected equipment. The equipment must be rated for use with conductors that have a temperature rating equal to or greater than the termination temperature rating. Article 408 of the NEC addresses switchboards, switchgear, and panel boards. These are electrical distribution devices that are used to control and protect electrical circuits and equipment. Switchboards are large panels that contain switches, fuses, and circuit breakers. They are typically used in commercial and industrial buildings to distribute power to various loads. Switchgear is a more sophisticated type of electrical distribution equipment that includes protective relays, metering devices, and other control components. It is typically used in large industrial facilities and power plants. Panel boards are smaller panels that contain circuit breakers or fuses. They are typically used in residential and commercial buildings to distribute power to individual branch circuits. Article 408 includes requirements for the installation, construction, and protection of switchboards, switchgear, and panel boards. It also includes requirements for the identification and labeling of circuits and equipment. It is important to install and maintain switchboards, switchgear, and panel boards in accordance with the NEC requirements to ensure the safety and reliability of electrical systems. Overload protection is a critical aspect of electrical safety. It is designed to protect electrical circuits and equipment from damage caused by excessive current flow. Overload protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when the current exceeds the safe operating limit of the circuit or equipment. Overloads can occur for a variety of reasons, such as too many appliances connected to the same circuit, a short circuit in a piece of equipment, or a motor drawing excessive current. When an overload occurs, the overload protection device trips and energizes the circuit. This prevents the circuit from overheating and causing damage to the wiring, equipment, or building. It is important to select overload protection devices with the appropriate ampacity rating for the circuit or equipment they are protecting. The ampacity rating should be based on the expected load of the circuit or equipment, as well as the conductor size and insulation type. It is also important to install overload protection devices in accordance with the NEC requirements. Short circuit protection is another critical aspect of electrical safety. It is designed to protect electrical circuits and equipment from damage caused by a short circuit. A short circuit occurs when there is an unintended low resistance path between 2 points in a circuit. This can cause a large amount of current to flow through the circuit, which can quickly overheat the wiring and equipment. Short circuit protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity very quickly when a short circuit occurs. This prevents the wiring and equipment from being damaged by the excessive current. It is important to select short circuit protection devices with the appropriate interrupting rating for the circuit or equipment they are protecting. The interrupting rating is the maximum amount of current that the device can safely interrupt. It is also important to install short circuit protection devices in accordance with the NEC requirements. Voltage drop refers to the decrease in voltage that occurs as electricity flows through a conductor. Voltage drop is caused by the resistance of the conductor, which impedes the flow of electricity. Excessive voltage drop can cause appliances and equipment to operate inefficiently or not at all. It can also cause overheating of conductors and equipment. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. For branch circuits, the voltage drop should not exceed 3%. For feeders, the voltage drop should not exceed 5%. To minimize voltage drop, it is important to select conductors with sufficient ampacity and to keep the length of the conductors as short as possible. It is also important to avoid overloading circuits, as this can increase the current flow and voltage drop. Power quality refers to the characteristics of the electrical power supply, including voltage, frequency, and waveform. Poor power quality can cause a variety of problems, such as equipment malfunction, data loss, and increased energy consumption. Common power quality problems include voltage sags, voltage swells, voltage transients, harmonics, and noise. Voltage spikes are temporary decreases in voltage that can be caused by the starting of large motors or the switching of heavy loads. Voltage swells are temporary increases in voltage that can be caused by the sudden reduction of load. Voltage transients are short-duration high-voltage spikes that can be caused by lightning strikes or switching of inductive loads. Harmonics are distortions of the voltage and current waveforms that can be caused by nonlinear loads, such as electronic devices and fluorescent lighting. Noise is unwanted electrical signals that can interfere with the operation of sensitive equipment. To improve power quality, it is important to use power conditioning equipment, such as surge suppressors, voltage regulators, and harmonic filters. It is also important to properly ground electrical systems and to avoid overloading circuits. Electrical safety is a critical concern for anyone who works with or around electricity. Electricity can be dangerous if not handled properly, and electrical accidents can cause serious injuries or even death. To prevent electrical accidents, it is important to follow basic safety precautions, such as always energizing circuits before working on them, using insulated tools, wearing appropriate personal protective equipment, and following all applicable electrical codes and standards. It is also important to be aware of potential electrical hazards, such as exposed wiring, damaged equipment, and wet conditions. If you are not qualified to perform electrical work, it is best to hire a licensed electrician to do the job. Never attempt to repair electrical equipment or wiring unless you are properly trained and equipped. Educate yourself and others about electrical safety to help prevent accidents and save lives. Electrical codes and standards are a set of rules and regulations that govern the safe installation and maintenance of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association, the Institute of Electrical and Electronics Engineers, and Underwriters Laboratories. The purpose of electrical codes and standards is to protect people and property from electrical hazards. They cover a wide range of topics, including wiring methods, conductor sizing, overcurrent protection, grounding, and equipment installation. Electrical codes and standards are constantly evolving to keep pace with new technologies and changing safety requirements. It is important for electricians, contractors, and other electrical professionals to stay up to date with the latest codes and standards and to follow them when performing electrical work. Compliance with electrical codes and standards is essential for ensuring the safety and reliability of electrical systems.